Okay, so I'm going to walk through the Module 9 review with you. Keep in mind, I'm going to go kind of quickly because you can always press pause and rewind if you need to see something I did a little bit slower or a couple of times. All right, first few questions on here, 1 through 5, are all pretty straightforward Pythagorean theorem. A squared plus b squared equals c squared, where the two legs, the two sides that meet at the right angle, are a and b, and the hypotenuse is always c. That's one reason I like to say not just a squared plus b squared equals c squared, but leg squared plus leg squared equals hypotenuse squared, because that's really what you're doing when you're doing the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. Okay, so on number 1, that would mean you would set it up 10 squared plus 24 squared equals x squared. When I square these and add them, I get x squared equals 676, and the square root of 676 is 26. Okay? Notice that that's a Pythagorean triple, 10, 24, and 26, because all three of those are whole numbers and they fit the Pythagorean theorem as three sides of a right triangle. Number 2, legs are x and 30, so x squared plus 30 squared. You always need to check first and think about where the hypotenuse is and where the legs are. So x squared plus 900, excuse me, that's an equals, not a plus, equals 34 squared, so that's 1156. This means I'm going to subtract 900 from both sides. X squared equals 256, and when you take the square root of 256, you get x is 16. Again, that's Pythagorean triple, 16, 30, and 34, because they fit as the sides of a right triangle. 16 squared plus 30 squared equals 34 squared. Number 3, the legs are x and 8. The hypotenuse is 12. So x squared plus 64 equals 144. Subtract 64 from both sides and you get x squared is 80. Now, this is not a perfect square, and up here it says round to the nearest tenth if necessary, so you can go ahead and put this in your calculator and get the tenths place, and that's 8.9 since it says that, or we can do it as a simplified radical. Simplified radical means I think of all the factors of 80 really, and think about the numbers that are perfect squares. Numbers that are perfect squares means 4 because it's 2 squared, 9 because it's 3 squared, 16 because it's 4 squared, 25 because that's 5 squared. These are perfect squares, the numbers I'm writing along the edge of my margin here. Okay, and these are the numbers that I'm looking to see if those go as factors into 80. Not go into 80 like they're smaller than 80, but go into 80 like those one of these times another number equals 80. And that's true for 4. It's also true for 16. We want the biggest one that's a perfect square that's a factor of 80. So we're going to say 80 is 16 times 5. And the reason I'm doing this is because now I can take the square root of 16 and say this right here is equal to 4. So instead of that, I'll put a 4 there. And that's my answer in simplified radical form. Number 4, 6 squared plus 5 squared equals x squared. 6 squared is 36. 5 squared is 25. When you add 25 and 36, you get 61. So 6 squared plus 5 squared equals x squared. You'll get 61 for x squared. When we take the square root of that, that means square root of 61. This says simplest radical form, so I'm going to see if I can simplify that. The answer is no, I can't. None of these numbers, I'm always looking for these numbers. None of these numbers are factors of 61. So I can't simplify it, so my answer is just the square root of 61. Number 5, x squared plus 13 squared equals 15 squared. That's x squared plus 169 equals 225. Subtract 169 from both sides. X squared is 56. Okay, so x is the square root of 56. And I have to look, once again, it's always back to this list. I'm looking at my perfect squares and thinking, are any of these factors of 56? That would be a yes on 4. 4 goes into 56 14 times. So I say this is 4 times 14, and the square root of 4 is 2. So I just replace that with a 2, and that's my answer.
Please come to the main office.
Okay, the scribble here again is me saying square root of 4, I could just write a 2 instead of. Number 6, this one takes a little bit more thought because you have to be careful when you are squaring that hypotenuse. The hypotenuse here is a binomial. I have leg squared plus leg squared equals, the whole hypotenuse is x plus 2. So I'm squaring that whole thing, which means I'm going to put parentheses around it. And the reason I'm doing that is to remind myself, when you square a binomial, you do not just get this squared plus this squared. It's not just going to be x squared plus 4. It just doesn't work that way. When you square a binomial, no matter what you're doing with it, and it just so happens to have that we're doing this in the course of the Pythagorean theorem, but this is really not about the Pythagorean theorem. This is just a basic algebra thing we might have to do anywhere. Squaring a binomial. So x times x, I'm doing FOIL, is x squared. X times 2, outer, is 2x. Inner, 2 times x is 2x. And last, 2 times 2 is 4. These two are like terms. I can simplify this and write x squared plus 4x plus 4. So that's what I get when I square that binomial. So that's what I'm going to get on the right-hand side. So I get 196 plus x squared equals x squared plus 4x plus 4. Okay, x squared and x squared, these two cancel each other out basically. If I subtract x squared from one side, it's gone from the other side. So we don't even need to worry about it. 196 equals 4x plus 4. Subtract 4. Subtract 4. 192 is 4x. Divide both sides by 4, and x is 48. So x is 48 for number 6. Number 7, this is another one I did in class. It says the aspect ratio of a TV screen is the ratio of the width to the height of the image. Width is across here. Height is here. A regular TV has an aspect ratio of width to height is 4 to 3. The way we're going to do this is we're going to say, let's call this 4x and this 3x. The reason that works is because if it's a ratio of 4 to 3, that means it's 4 times some number and 3 times some number. It always works that way for a ratio. So find the height and width of a 42-inch TV screen. The 42 inches, and it tells me this, is the diagonal. So this is a right triangle, and I'm going to use the Pythagorean theorem. So I have leg squared plus leg squared equals hypotenuse squared. So 4x squared plus 3x squared equals 42 squared. 4x squared is 16x squared, 3x squared is 9x squared. Don't forget to square the number. That's a common mistake. And then I have 42 squared, and I get 1764. So this is 25x squared equals 1764. Divide both sides by 25. 1764 divided by 25, I get 70.56. I'm going to take the square root of both sides to get the x here. Square root of 70.56 is 8.4. X is 8.4. The question asks me for the height and the width, so I have to go back and plug in this 8.4. When I plug in 8.4 here, I get 25.2. So the height is 25.2. And when I plug in 8.4 here, 4 times 8.4 gives me 33.6. So the width is 33.6. Now number 8, I said don't worry about, you're not going to have one just like number 8, but let's go ahead and look at it. Number 8 says a widescreen TV has an aspect ratio of 16 to 9. Okay, so that's referring to the same two things, the width and the height, that we were just talking about. Find the length of the diagonal. We don't know what this is, okay? But it did tell me that it has the same height as the screen in exercise 4, which is kind of interesting because there wasn't a screen in exercise 4. I don't know what they're talking about here. I'm assuming it means the screen in exercise 7, the one in the previous exercise. So we're going to go ahead and do that. The screen in the previous exercise here, this would be the 9x here. We just did it. It was 25.2. Okay, so that means let's say that 9x equals 25.2. Okay, if 9x equals 25.2, I'm going to solve and figure out what x is. So I'm going to divide both sides by 9. And when I divide 25.2 by 9, I get 2.8. X is 2.8. We already know this is 25.2. If I know that x is 2.8, I can find this width as well. So I have 16 times 2.8. 16 times 2.8 gives me 44.8. So now I have the width and I have the height. So now basically this becomes a problem of just doing this. You have a right triangle. Here's one side. Here's the other side. And we have to find the hypotenuse. So we'll do 44.8 squared plus 25.2 squared, and I get 2,642.08, and then I take the square root of that number, and I get about 51.4 is my diagonal. Okay, again, you might have to do one like number 7, but you won't have to do one like number 8 here. Numbers 9, 10, and 11. You're doing the same thing you did above here. This would be 6 squared plus, let's call it x squared equals 6.5 squared. And when you do that, you should get 2.5 for x. But the other question is, do the side lengths form a Pythagorean triple? That would mean they would have to all three be whole numbers, and they would have to work for the Pythagorean theorem. They'd have to be sides of a right triangle. 6.5 is not a whole number. So this one, even before you start, you know the answer is going to be no. This is not going to form a Pythagorean triple. Number 10. These two are the legs, 15 and 20. 15 squared plus 20 squared equals, and then we're going to find out this hypotenuse is going to be 25. So 15 squared plus 20 squared equals 25 squared. 15, 20, and 25 are all whole numbers, so that would be a yes. Number 11. These are the two legs, 3 and 9. So 3 squared plus 9 squared. So when I do that, I get 9 plus 81, and I get 90. So this is the square root of 90. Well, square root of 90 I can simplify, and I get 3 root 10. Because square root of 90, 9 goes into there 10 times, and 9 is a perfect square, so square root of 9 is just 3. However, this number is not a whole number, 3 root 10. If you have a radical in the simplest form, or you have a decimal in the simplest form, that's not a whole number. So this is not a Pythagorean triple. Next page. For anything about 12, 13, 14, 15, there is a separate video on the web page. Please look at that. Down here, number 16. 16, 17, and 18, these are all 45, 45, 90 triangles. Remember that in a 45, 45, 90, you only have to worry about one number, and that is square root of 2. In a 45, 45, 90, I'm either going from the legs to the hypotenuse, because the two legs are exactly the same. So I'm either going from the legs to the hypotenuse, which means I'm multiplying by square root of 2, or I'm going backwards from the hypotenuse to the legs, which means getting smaller and dividing by square root of 2. Number 16, we're going from legs to hypotenuse, so we're multiplying by square root of 2. If you take 8 root 2 and you multiply it times the square root of 2, square root of 2 times square root of 2 is just 2. Anytime you have a square root times itself, it's just the number. So this is 8 times 2, and the answer is 16. Number 17. This time we're starting with the hypotenuse, so we're going backwards. We're going to have to divide by the square root of 2. Anytime you're going to divide by the square root of 2, that means write it on the bottom. Then, however, we cannot leave it on the bottom, so we multiply by square root of 2 on both top and bottom. And on the top, that gives me 7 times the square root of 2, and on the bottom, square root of 2 times square root of 2, again, is just 2. So that is my answer. I can't simplify this because 7 does not divide by 2. And last but not least, on number 18, again, we're starting with the hypotenuse. If you're starting with the hypotenuse, you're going to divide by square root of 2, not multiply by square root of 2. Again, it's always square root of 2 for 45, 45, 90. Divide by square root of 2 means put it on the bottom, and look what happens. This is going to cancel. That's just 2. So x is 2. Numbers 19, 20, and 21, these are 30, 60, 90s. Remember, for a 30, 60, 90, you've got two numbers. If you are going from short leg to the long leg, it's times square root of 3. Which means if you're going from long leg back to short leg, that would be divided by square root of 3. If you're going from short leg to hypotenuse, that's times 2. Which means if you're going from hypotenuse back to short leg, that's divided by 2. So on number 19, the first thing I have to look at is which leg am I starting with? On number 19, I'm starting with the short leg, so that's convenient. I'm going to multiply the short leg times square root of 3 to get the long leg. So here's the short leg, times square root of 3 gives me the long leg. Square root of 3 times square root of 3, remember, is just 3. So this is going to be 30. So the long leg x is 30. To get the hypotenuse, you don't go from the long leg, you go back to the short leg. Short leg times 2 gives me hypotenuse. 10 root 3 times 2, 10 times 2 is 20. So there's the hypotenuse. So the long leg is 30, x is 30, and 20 times the square root of 3 is y, or the hypotenuse. Number 20, we're starting with the long leg. Here's the short leg over here. So we're starting with the long leg. Long to short or short to long, both ways, we deal with the number square root of 3. Since we're going from long to short, that means I'm trying to get smaller. So I divide by square root of 3. Remember that if you have a radical in the denominator, you've got to get rid of it. Multiply by that radical on top of itself. Square root of 3 times square root of 3 is just 3. This one can simplify. Unlike this one up here, I said 7 and 2 don't divide. 12 and 3 do. So 12 over 3 is just 4 over 1. I don't have to write the over 1. It's like it's down here, but we don't have to write it. So 4 times the square root of 3 is what x is. So x is 4 times the square root of 3. Then short leg times hypotenuse, short leg to hypotenuse, the number we deal with is 2. If I'm going from the short leg to the hypotenuse, I'm trying to get bigger, so I multiply by 2. 4 root 3 times 2, 2 times 4 is 8, so 8 root 3. Number 21. Number 21, it might seem kind of confusing at first. It doesn't start with the long leg, that starts with the hypotenuse. And remember, the rule between hypotenuse and short leg is divide by 2, or multiply times 2. The number is 2. But I know it's division this time because I'm starting with the hypotenuse, which is the biggest side, and going to the small side. So hypotenuse divided by square root of, hypotenuse divided by 2 will give me the short leg. If I divide this by 2, that just gives me square root of 3. So the short leg is just square root of 3. Short leg times square root of 3 gives me long leg. So I'm going to take that short leg, here it is, and multiply it times square root of 3 to go from short to long, and that just gives me 3. So my long leg is 3.